Hello friends, today's question: water from a pipe is coming out at a rate of 100 liters per minute. If the radius of the pipe is 5 centimeter, the Reynolds number for the flow is of the order of. So we have to find out the order of the Reynolds number, and we are given the density of the water as well as the coefficient of viscosity of the water. So this question is quite simple and it's directly based on the formula. Only thing we have to take care in this particular question is about the units, because flow rate is given as 100 liters per unit, radius is 5 centimeter, and viscosity is given as 1 millipascal. Okay, so we have to try to adjust all the units. That's the only tricky part here. Rest it is directly based on the formula. And the formula for a Reynolds number and it is represented, suppose, RE, and that is given as rho V d upon mu, where rho is the density of the liquid, in this case that is water. So rho is density of water, and that is given as 1000 kg per meter cube. V is the average velocity of the liquid, in this case water. So V is the average velocity of the water, which we are going to calculate, and we have D is the diameter of the pipe, which will be equal to 2 into the radius in centimeter, so we convert it into the meters. And we are also given as mu, that is a coefficient of viscosity. Mu is dynamic viscosity of water, or we can say coefficient, and that is given as 1 millipascal, and that will be equal to 1 into 10 to the power minus 3 pascals. So only thing we have to calculate is the average velocity, and rest of the parameters are given directly to us. So let us start with the average velocity. Of water, and that is given as V, and this V will be equal to flow rate divided by area of the cross section of the pipe. Area of cross section of pipe, or we can say Q upon A, and Q is given as 100 liters per minute. Q is given as 100 liters per minute. So first of all, we convert that into the meter cube. So this will be 100 upon 1000 meter cube per minute, and then we convert this into seconds. So this will be 100 divided by 1000 multiplied by 60, and now we have meter cube per second. And next is our area, and area is our pi r square, and we are given the diameter that is in centimeters, so this becomes our pi multiplied by 0.05 whole square. Okay, so this we can write pi multiplied by 0.0025. So therefore we can write that our average velocity V will be equal to Q. Q is our 100 divided by 1000 multiplied by 60, and now we divide it by area, and area is our pi upon this will be our multiplied by 25. Removing the decimal, we get this as 100 and this as 100. So we just try to solve it, and these two goes with this two, and these two goes with this one, and we are left with here as this goes by 4, this goes by 2, and this goes by 3. So we are left with, sorry, 2 is left here, so we get this as 2 upon 3 pi. So this is average velocity. Now we are going to simply substitute it in the equation 1. Let us call this as equation 1 because we all know all the parameters. So therefore the Reynolds number, so using equation 1 we get Reynolds number is equal to, we have 1000 multiplied by 2 by 3 pi and multiply by, we are required for diameter we have 2 multiplied by the radius, that is 0.05, and divided by, we have our mu, that is the coefficient of viscosity, which is 1 into 10 to the power minus 3. And in this case we can say that this 3 pi is approximately equal to 10. Okay, for the sake of convenience, let us say this 3 pi is equal to 10 because the answer is in the form of the powers of the 10. So if we solve it, we can say, let me substitute the value here. First of all, this we get Re will be equal to 1000 multiplied by 2 upon, this is 3, and here we have, sorry, 10 multiplied by, and we have here this is now 2, so 5 upon 100 multiplied by 1 upon, and this becomes 10 to the power 3. I think all the parameters are covered. Yeah, all the parameters are covered. So if you solve this, we can easily see that this Reynolds number will be approximately equal to 10 to the power 4. So we have to find out the nearest one is the order of. Okay. So we check the options available to us. Option number B is the correct option. You can see option B is correct. So this question, you can say, was quite simple, except for the, you can say, the different how can you put it, different parameters were given to us in terms of different, the units rather, like 100 liters per minute was given and we converted that into meter cube per second, and viscosity was given in millipascal. So that was the only thing. Rest is based on the direct formula for this Reynolds number. So this completes the question. Thank you.